Hello, everyone, and welcome to our Automation and Programmability webinar series. My name is Nabil Mishraf. I'm a solutions architect in the automation team at Cisco. And with me today is Wei, who will do the presentation for this topic. Wei will discuss autonomous network and level of automation. Just a couple of housekeeping rules before we start. Please use the Q&A section. You'll find that at the bottom there are three dots at on the bottom right. If you do Q&A on the right side. So use Q&A for any questions that you may have during the presentation. Don't use the chat for questions. Of course, you can use the chat, but don't use it for questions because Q&A we can track answers to the question. So we may be able to answer these questions live, or we'll wait till the end of Wei's presentation. I will also make the recording available after the end of this webinar, maybe later today. And with that, Wei, you can take it over from here.
Sure. Thanks, Nabil. Okay. Hello, everyone. So my name is Wei Tai. I'm a solutions architect in the network automation and programmability team in Cisco's mass scale infrastructure group. So as Nabil said, I'll be talking to you about autonomous networks and network automation being its key enabler. Okay, so here's the agenda. I'll first introduce to you the definitions of autonomous networks and network automation. I'll briefly describe the levels of driving automation that has been introduced in the automotive industry. And borrowing from the concepts of the levels of driving automation, I'll introduce to you the levels of network automation that we have defined and how model-driven network services has formed the foundation for a network to become autonomous. I'll then cover the levels of autonomous networks as defined by the TM Forum. And lastly, I'll discuss with you a framework that has been introduced to support autonomous networks. And then I'll conclude with an example automation solution from Cisco that demonstrates where we are in our journey towards building a fully autonomous network. Okay, so what is an autonomous network? It's a fully autonomous network runs without human intervention. So it can handle self-configuration, self-healing, self-optimizing, self-evolving, and it provides the best possible user experience. There will be zero wait time, zero touch, and zero trouble services. It is the ultimate goal of fully automated network operations that all CSPs are or should be striving for. And a key component of autonomous network is network automation. So what is network automation then? Network automation is the process of automating the configuring, managing, testing, and operating of physical and virtual devices within a network. And network automation is used to improve efficiency, reduce human error, network service availability, and lower operating expenses. So why would you want to automate your network? Well, growth of data and devices is starting to outpace IT capabilities, making manual approaches nearly impossible. Network operational costs are 2 to 3 times higher than the cost of the network itself. And increased IT automation is essential to keep pace with the network growth. So based on Cisco's study, you have up to 95% of the network changes today are still being done manually. And manual changes lead to configuration errors and inconsistencies in the network. Expanding network changes at scale can be problematic. And network downtime and non-remote troubleshooting time are detrimental. So what are the drivers for introducing automation into operations? So based on a recent survey conducted by the TM Forum, if we start with this part of the ring here, there are 20.5% of the respondents to the survey that said, we are introducing new technology, such as virtualization, that necessitates operations at speeds not feasible for manual processes. Then we have 28% of the respondents that said, we need to change processes or settings, such as provisioning, more often and more quickly than manual processes allow. Then you have 6.5% of the respondents that said, we have new process requirements that are more complicated and change more often, such as partner onboarding for IoT, than manual processes can cope with. Then here's a big percentage, and 42% of the respondents said, we would like to introduce new services that require faster and more complicated responses from operations, such as on-demand services, than manual processes can provide. So not all network automation is created equal. Anything that moves work tasks from a human operator to a computer is called automation. So how do you quantify the achieved level of network automation? Hence, we have defined 5 levels of network automation, which classifies varying levels of automation. This is analogous to how the auto industry has defined the autonomous driving levels. So let's briefly talk about the levels of driving automation that has been defined by SAE, or Society of Automotive Engineers. I provided a link down below on the wiki page that defines self-driving, that talks about these levels. So you have level 1, there's no driving automation, and then slowly progressing up, you have driver assistance is level 1, partial driving automation is level 2. So all those 3 levels require the drivers to be fully engaged in supervising these driving support features and take over driving as needed to maintain safety. Then starting with level 3, we have conditional driving automation, level 4, high driving automation, and level 5, the highest level, full driving automation. So these 3 levels, 3 through 5, they provide driving features that don't require the drivers to be engaged, except for level 3, under certain cases that the system itself will notify the driver to take action if it's something that it cannot handle. So notice that it says conditional driving, right? Starting with level 3. So conditional typically means that it's sort of a very controlled environment, meaning that it's something that the system was designed in sort of a lab controlled environment, that it does not, or is not able to handle all situations, all real world situations. So now let's move on and talk about the levels of network automation that we have defined. So before I go into details of defining each network automation level, I'll first describe the environment and the context in which these levels are relevant. So our focus is on automating network services. So on the left of the slide, we have service orchestration that is happening across multi-domain and multi-layer. You can also call this the management system. Then on the right, these are this example network services that are being orchestrated or being managed. So the management systems or the service orchestrators configure services in the network to provide value to the users of the network. Usually, there are many types of services and many instances of each service type. For example, a service could be internet connectivity for a residence or a point-to-point layer 2 Ethernet connection. Services can be stacked. For example, one service can create or call another service in order to form the full service. For example, to provide an internet connection, a layer 2 Ethernet connection from the customer location through the access network to the nearest edge router needs to be created too. And the network can also be divided with a management system managing over its own domain. Another example, the access network can be managed by one management system, and the edge routers providing internet connectivity are in another domain. The management system of each domain can talk to the management systems of other domains. So this is the backdrop for defining our levels of network automation. Now let's start with network automation level 0 that we are calling text templates. So as you can see on the left side of the slide, you have a human operator typing CLI commands by following a MOP or a method of procedure. So a MOP is a document that describes a sequence of tasks to perform in order to reach a goal. It's a little bit like a computer program with a sequence of instructions, just that it's intended for a human to process and carry out those instructions. So copy and paste of CLI configs can be considered by some as automation, as it reduces the amount of typing required by the human operator. There are MOPs for handling different situations, such as the installation of new customer circuits or what to do when a link goes down. Old service instances are rarely updated when the MOP template is updated. So MOP instructions aren't always carried out the same way by different operators. If a decision needs to be made for carrying out a particular instruction, the outcome will depend highly on the experience level and skill set of the operator. So the largest drawback of this level is a major risk of human error. For instance, pasting the correct configuration, but into the wrong CLI terminal window. Involuntarily causing a L2 loop might turn your L2 network with 164 devices into 164 isolated L2 networks. This automation level doesn't scale well from the operational cost perspective, as the need for human operators grows with the size of the network and network services. So let's move on to the next level, the network automation level 1, macro scripts. So here we're automating MOPs as scripts. So a script will take as arguments the variables that were listed as placeholders in the MOPs. The input arguments together with the stored configuration template is expanded to configuration that can be sent to a device. It is equivalent to macro expansion. The scripts are running in what I would call the blind mode. with little to no checking of preconditions and completions. So since there are no or few checks, it is rare that an error is detected by the script. So the improvement with this level is that you get accelerated network service configurations with only slightly higher investment cost. However, the drawback, the network can be easily left in an inconsistent state for the operator to resolve. And it's not as flexible for the human operator to solve problems ad hoc, because now you have scripts in the way and mixing it with manual typing of CLI commands. So it's a little bit messy. Okay, now we have the next level, the network automation level 2, adaptive activation scripts. So this level is fundamentally similar to the previous level, the macro scripts. You can still call it the enhanced macro scripts, but with some logic sprinkled on top. First, there will be proper pre-flight checks to see that the environment is properly prepared for the commands to run. And certain information or facts can be retrieved from the target. And this information is in turn used to affect the configuration. For example, a configuration section can be skipped if it is found to already be configured on the target device. After the command has run, there will be proper post-flight checks to see that the desired goals have been reached. So the improvement with this level, the adaptive activation scripts, is that it provides even quicker service activation as compared to the previous level, and it can handle full service lifecycle. The restoration of previous good state typically relies on the rollback functionality of the target device, or it is manually implemented as the inverse of the applied configuration, which means that it's quite brittle and prone to going out of date. It can be difficult to maintain over time with service definition changes. So manual intervention is required under certain error conditions that are not handled by the scripts. Moving on to network automation level 3, the model-driven services. So levels 1 and 2 depend entirely on a programmer to foresee all situations the system should deal with inside the scripts. A MOP would consist of a sequence of such messages that gets the particular task done. It is up to the programmer to figure out a sequence of messages that work, and he can do that by using any kind of tools, prior knowledge or through trial and error. Once a working sequence of messages is determined, it's just a simple matter of making sure the management system replicates that sequence to carry out the operation. There's no dependency on any sort of standards. And as long as there is a workaround for any issues found, the handcrafted messages can be updated to avoid the problem. And the network may not be able to be brought back to a known good state if something out of the ordinary happens. Now with this level 3, the model-driven services level, you have the service models describing the network services and the device models describing the device's behavior. So here is showing that with this approach, that you have the service model that takes input from the user or from the operator, and internally those input taken will then be mapped to configurations on the device based on the device model. So when a service is created, it will be mapped to the list of device configurations that have to be configured on the device. And those configurations are stored inside of the orchestrator here. Then when there are changes that needs to be made to that service, a new device configuration will be calculated, and it will be compared with the previous device configuration. And then the differences will then be sent to the device and also be stored in its own database. And lastly, since the configs is stored in its database, it's very easy to be able to delete the device configs if a service needs to be deleted. So with this more sophisticated level, the management system is able to send commands that it has computed on its own, messages that are tailored to the current situation and desired goal. You can perform any kind of operation with this approach. Reversing the previously applied change is possible by computing the inverse from the data model. And further, with updates to the service definition, a model-driven approach can automatically compute the necessary configuration changes to bring a service from version 1 to version 2. So the improvement here with this level is that no longer needed to what has been programmed in the scripts. We're no longer limited to what has been programmed in the scripts. And it can handle creation, deletion, and any kind of update. And the drawback is that the quality of this is that it's highly dependent on the abstraction of the current device state and the execution of the config commands and abstraction of the device behavior. So pretty much we depend highly on how well the system is being modeled. So let me describe further how the model-driven services approach work using Cisco's NSO product. So here we have the service model sitting on top, in which the service instance data is being mapped to the model-driven device config data. So a synchronized copy of the config that are being sent to each device is being maintained in NSO's database. And it keeps track of every change for every service on every device in the order in which it was made. It has the ability to roll back a change to a specific version or dry run its possible change against its database. By dry run, I mean that you can try something out without sending the actual device configs to the device. The service model captures all of the intelligence that are needed to configure the service. So at runtime, the service model directs the orchestrator to collect the needed input. Then it plugs that input into the model. The model generates the service config for each device in the service chain, as shown here. It then, in a single transaction, it pushes that config to all the devices. If for some reason any one change fails, the entire transaction rolls back. So the service is never partially configured. The transaction either works or it rolls back. So now the system is no longer dependent on code that were prepared by a network programmer and the programmer's ability to imagine and work through a huge number of scenarios. The model-driven services approach provides us with a solid foundation to build out more sophisticated network automation. Now, the next level is network automation level 4. verified service delivery. So while level 3 can reliably take our network from any state to any other, level 4 adds verification that configuration services are being delivered as intended and meets service level agreements. So proper service monitoring involves measuring the direct KPIs. And we should strive to measure the direct KPIs of a service. For example, for a layer 2 point-to-point connection, we can't just judge if the service is working just by checking if the interface to the customer is operationally up. We also have to send traffic across the connection to gauge latency and similar metrics. For a corporate internet connection, we can monitor the BGP session to make sure that it is up and both sending and receiving the proper routes, but we should also send actual measurement probes to verify connectivity. So the improvement with this level is that there's now proactive monitoring of individual service instances to keep the customers happy, to make sure that their needs are being met. And as for the drawback, that human intervention is still required in order to resolve issues from meeting the SLA if there's any problem that happened in the network. Moving on to network automation level 5, closed loop. So level 5 adds automatic recovery and optimization. The full service lifecycle is now automated. And once in a while, the continuous service instance monitoring from the previous level, level 4, might indicate that a degradation of delivered service quality, or even a breach of the SLA or total loss of service. The management system will then re-examine the service instance and see how it could be redeployed to deliver the expected service. So the improvement is that you get automatic service redeployment to fix breach of SLA issues. And you also get automatic optimization of network resources. And with the full service lifecycle automated, including day-to-day error handling and optimization, there's still plenty of work to dig into. So you still have handling of exceptional situations, such as bugs in devices, exotic hardware failure, cyber attacks, or forest fires will be part of it. And planning the network evolution, both in terms of equipment and services. Optimizing the internal processes, since the need to become leaner and faster will never end. And maybe even getting time to develop new services and revenue streams. Although our level of network automation scale ends at level 5, the area of network operations certainly encompasses more than I have covered here. For example, you have capacity planning of the network, which requires not only the notion of the current state of the network and also our desired state, but also a view into the history and the future, such that we can base future predictions of network usage on historic data. We need to predict when links become full and plan capacity upgrades accordingly. So would you call that a level 6? Or should we consider it a separate component with its own defined levels? So regardless, there are vast areas of common operational procedures that we as an industry can automate. So here's a summary of the levels of network automation. So you have levels 0 through 2 that require the human operators to be fully engaged in carrying out the automated tasks and handling error conditions. And you have levels 3 through 5 that provide network automation features that require decreasing level of human intervention. And now let's revisit how this network automation tie into the autonomous networks. So these are the levels of maturity model for autonomous networks as defined by the TM Forum. So you have level 0 for manual operations and maintenance, level 1 for assisted operations and maintenance, level 2 for partial autonomous network, level 3 for conditional autonomous network, level 4 for highly autonomous network, and then finally, level 5, the highest level, is a fully autonomous network. So each level of the maturity model has a set of characteristics describing the evolutionary stage of the CSP's journey from fully manual to fully autonomous operations. So according to TM Forum study, many CSPs are currently at level 2, partially autonomous networks with limited autonomous capabilities. Some advanced CSPs are operating some network domains at level 3, conditionally autonomous networks, intent-based automation based on real-time changes. CSPs will not implement autonomous networks in a short time frame. It is a journey that requires CSPs to adopt a stepwise approach according to a model like this. It is forecasted the journey to fully autonomous network is expected to take at least a decade. So with the levels of maturity model defined for autonomous networks, we need a framework for realizing the fully autonomous network. So this framework for intent-driven, fully closed loop autonomous network has been defined by Analysys Mason a few years, 2 years back. And it is centered around the idea of building customer and service-oriented autonomous networks. So intent-driven operations are a fundamental principle of this new operational model. So this framework starts with the definition of business intent by the customer, which is the declaration of a business objective. For example, an enterprise demanding to set up branch and WAN connectivity or deploy a new IoT application. An autonomous network should fulfill the business intent using service policy, design, orchestration, and AI analytics capabilities in a fully closed automation loop across design time and runtime operations. So the business intent must then be translated into service intent through service orchestration by decomposing the business intent into various steps and mapping them to service requirements and relevant network resources. So network orchestration converts this service intent into network intent. It instantiates and activates the networking resources associated within the service, with the service within specific domains, as well as across domains. It also validates and monitors the network and service and performs analytics-driven automated actions in order to self-heal and self-optimize the network to resolve issues before they impact service quality and customer experience. So the insights and patterns generated by AI and ML, artificial intelligence, and machine learning tools also drive the automation of the service design and network and resource planning processes. So to achieve the level 5 multi-domain autonomous networks, CSPs need to implement a hierarchical cross-domain automation architecture that collapses network silos, simplifies network domains, and transforms the underlying network into a platform by abstracting the underlying complexity. So the use of industry standard model-driven approach to access the network in a standardized way to manage both the network services and the devices will be key enablers for this. So I'll conclude with showing you an example of a network automation solution that is in its journey towards delivering on the objectives of autonomous networks. It is Cisco's crosswalk network automation that is designed with modern low or no touch operations in mind. It is multi-vendor and multi-domain, centered on both programmatic infrastructure control and access to operational and state data, and spans both cloud, SaaS, and on-prem tooling. So the tools in crosswalk encompass the full service lifecycle and deliver a closed operational loop that includes planning and design, implementation, and ongoing monitoring and assurance. The approach taken here is rather similar to the framework as shown in the previous slide. So to implement closed loop operations, you need the operational capabilities of visibility, insights, and action. With visibility, it provides you with a consolidated views on state and operations for both human and machine consumption. With insights, it gives you operational intelligence on health and trending of services underlying resources. And with action, it gives you the ability to plan, design, test, and implement changes with both on-prem and cloud tools. So during our journey towards a fully autonomous network, there will be a period of time that equipment providers need to build trust with the service providers on automating the closed loop. For example, Cisco's Crosswalk Network Controller solution has a feature called Local Congestion Mitigation, or LCM, that provides localized mitigation recommendations within surrounding interfaces with the use of standard protocols. So data is gathered in real time, and when congestion is detected, solutions are suggested. However, LCM still has a human in the loop aspect, which ensures that the control of making changes in the network still lies in the hands of the operator to give them peace of mind as the technology becomes more mature. So this isn't unlike how semi-autonomous driving work today. When a suggestion is made by the car for the driver to change lane as it is approaching an exit, it needs the driver to confirm by the push of a button before it will change lane. So this is a necessary step before we can reach the last step of the maturity model for achieving autonomous networks. Another example is Cisco's Thousand Eyes product. With its predictive network intelligence capability that doesn't just leverage machine learning to understand what's happening and what might be wrong now, but actually predicts outages that have yet to happen and will allow the operator to remediate them in real time. So this fits really nicely with the mission that we all have of shifting from reactive to proactive in our automation journey. For now, there will be a human in the loop, and recommendations have to be longer term until it gains the trust from customers to allow it to automate the remediation. So as IT teams accept these recommendations more frequently, and eventually they will be open to pushing the remediation automatically. So we're hoping that we will gain that level of trust and have people closing the loop and do fully predictive remediation in a fully automated way in the near future. So this concludes my talk. Thanks a lot for listening. Do we have any questions, Nabil?
Yes. Hi. Thank you, Wei, for the presentation. So we have 3 questions so far. I assigned all of them to you. Maybe you can see them on your QA tab.
Okay, let me close
If you
out
don't,
of
I
this.
can.
No, sure. Let me close out of the presentation and
It's on yeah, can reduce it.
stop sharing. Okay, make it
Yeah,
easier for me to see the questions.
Yeah, it should be on the right side. I mean, you might need to share again, but let me know if you don't see them.
Q&A. Yeah, okay, I got it.
Okay.
So the first one, how do you handle the case where a convergence event must be handled, requiring some time delay before validating that the changes were correct? There are some redeployment that may have to be handled. I mean, the model-driven services model, there are ways that it can make sure that it converges. So certainly it can be handled. For example, NSO does have capability to handle that. And the second question, where can I find this slide deck for my future reference? Okay. You have answered that already.
So for level 5 automation.
Okay, I see. What happens in level 5 when the solution is to add more bandwidth or more compute resources in order for service to meet SLA? Well, so that will be something that has to be probably achieved even beyond level 5. It's something maybe capacity planning, as I mentioned. So it may have to be handled at level 6 or be handled by another model. So certainly our level 5 does not handle everything that is required to achieve a fully autonomous network.
So in other words, in level 5, the expectation is that the network elements can handle the service. So they have enough resources to handle the service from a hardware perspective.
Correct. It does not handle capacity planning.
Right. Okay, so the question for level 5 automation, how much packet metadata do you need to analyze in order to get additional insights on the network? And how frequently do you need to sample network data? I think this takes us to telemetry.
Yeah. Is this a question on my panel as well? Or?
It's a question that I sent to you as well, but maybe you don't see it
I
for
see it
some
now.
reason. Okay.
Level 5 automation. How much packet metadata do you need to analyze to get additional insights on the network? How frequently do you need to sample network data? Unfortunately, this is not something that I know off the top of my head. So I cannot provide an answer. This is something that has to be handled by the closed loop automation, right? It's something that we have to look at the telemetry data, perform the analysis, and then determine the frequency that is needed in order to be able to recommend something meaningful or automatically perform an operation on the network that would allow it to meet the SLA.
Right. So this is part of closed loop
Right.
telemetry data. Okay. These are the only questions. If anyone else has more questions, please post them here in Q&A. We have a few minutes left. All right, so no questions. That's good. Either way. Wei, thank you so much for your for the presentation. It was great insights into all the levels of automation and what needs to happen. I will share the recording later on today with everyone, so monitor your email. And we have one last question here. Is network verification a part of your system? I'm not sure what
Which system is being referred to here?
Yeah, if you could clarify also what you mean by network verification.
Let me, is the question referring to level 4 or level 5?
Well, let's assume it's level 5 for now.
Okay. And what is the question again?
Yeah, I think this is the way it's too it's not clear enough for us to guess, because there are two components here that we need to check. Oh,
right.
At what level is Cisco today?
Well, I don't think we have an opinion on this. If I would have to take a guess, we are probably more like, oh, what level of what though? I'm sorry. Could talked about many different levels here.
Automation level, so 1, 2, 3, 4, 5. So which level is Cisco today? This is more general question.
Well, then certainly we have, depending on the domain, right? We certainly have reached automation level 5 in certain domains.
In certain areas, yeah.
Yep.
Okay. Does any of this overlap with DNAC, automation / analytics? This definitely applies.
It certainly overlap. It certainly applies to DNAC as well, because it's intent driven. It's intent based networking, right? So they certainly overlap each other.
Any thoughts on how to improve managing underlying physical and managed network infrastructure in a closed loop model? Example, fiber and cross connects.
Well, I think the key to closed loop would be being able to collect the right set of data and being able to perform analytics on it, right? In order to be able to detect failures. And as I mentioned, the example that I mentioned about thousand eyes, right? I mean, ideally, you want to be able to predict possible failure in the future, as opposed to waiting for the failure to happen and then react, right? So that would be how I would see things would move towards, relying on AI and machine learning.
Mm-hmm. Yep. Okay, I think this is the last question. So with that, thank you everyone for attending. And again, I'll send you the recording later today. Thanks, Wei. And we can end this meeting now.
Okay, bye everyone.
All right, bye everyone. Thank you for the clap.